Welcome to another RDWorks Learning Lab. We might be making a bomb today. I say might. I hope we won't, but there's always the chance. Because what I'm going to be today doing is I'm going to be working with the air assist on this machine. And one of the questions that's popped up regularly is it good to have pulses or no pulses coming out of my air assist? I don't know the answer to the question. I mean, it works very well with pulses, but maybe it'll work better without pulses. I hope I'm going to be making a small pulse killer here today rather than a rust killer. Basically it's a jam jar, and I've got a couple of fittings on the top which will allow me to feed the air in and out so that the pulses will get absorbed inside here before they travel down the tube. Now, to try and aid that, first of all, I've made sure that the out tube has to come out from the bottom of the jar and the in tube goes in at the top. And then what I've got here is some very open fabric wadding, which is the sort of stuff that your mum might use or your sister might use for making quilting. This is a material that you can buy in your drapery store, in your haberdashery store. So the plan is to make sure that there is a complex path between what comes in and what goes out. I'm going to wrap this in this wadding and we're going to jam it in the jar, and that's why it's called a jam jar. There is actually more resistance there than I thought. Well, to be honest, I think there's too much resistance the more I think about it. So I shall just reduce the resistance a little bit by cutting some of the wadding away. So we've taken some of the wadding out and we'll jam less into the jam jar. That's better. That's better. It feels like there's very little resistance there now. And I think if anything's going to give, it's going to be these tubes blow off. But just in case, we'll put a little bit of physical protection over the top to make sure that nothing comes upwards. Okay, well, I've got the machine turned off because I want to actually hear what noise is coming out of this nozzle. So I'm going to turn the pump on and we'll listen for the bang or not. Well, I have to say that sounds pretty successful. And if I put something in front of the airflow, it sounds pretty stable. I've taken the pulse limiter off. Okay, I've taken the jam jar off. And now we'll take a listen to how it was previously. Not a lot different, to be honest. So there is not a tremendous amount of pulsing going on there. So no, I'm not going to change anything. I'm happy with the airflow there like that. That's sufficiently damped by the fact that it's coming out of a 10mm pipe and it's eventually finishing up through a 4mm pipe, which is causing the damping effect and getting rid of most of the pulses. But the biggest problem is the pump doesn't automatically turn off, and especially if you listen to the pump, when I turn the airflow off, the pump is stalled. It's working very, very hard. I'm just about to put the automatic air assist on this machine, and one of the problems is that most of the time the machine will be sitting here just like this with the control valve closed, just the merest leakage going through there. I don't like the fact that the pump is spending so long working in a stalled condition. So as part of this air assist upgrade that I'm going to do on this machine, we're going to make the pump switch off as well. So let's take a quick look at the circuit diagram and show you where we're going to. Here we've got our mains supply, which is controlling the air pump itself. What I've done, I've intercepted the supply for that pump, and I should be passing it through a relay. And this is a 24 volt relay, 24 volt DC, because it's driven off of this 24 volt DC supply here. Let's just quickly work our way through the air circuit before we talk about how we're going to control it. When the air pump turns on, the first thing that the air does, it comes round here and it meets up with a solenoid valve. This is an air solenoid valve from a company called SMC, which are big in pneumatics throughout the world. So wherever you are, you'll be able to look up to find out who your local supplier of SMC parts is. Now, I've used SMC parts because I know what they are. Now, this is supposed to be a 2-position 3-way valve, and here it shows 2 positions and it's got 3 outlet ports. Okay, now this I bought off of eBay for probably half the price of that, and this claims to be a 3-port valve as well. In truth, it is, but it's a special sort of 2-way 3-port valve. If we take a look at it, we'll find that there are ports on the back and the front and the side, and you think, well, that's got 3 ports on it. No, that's only 2 ports, because what this normally does, this would normally sit, I'll just loosen this off for a second, this valve would normally sit next to another valve, and you have an O-ring seal on here, and you have a whole load of these pulled together with a long thread. So you could have 5 or 6 of these valves all stacked together, fed by one air supply, one common air supply right through the middle of them. And that's what this is. This is a common air supply. And so it's not 2 ports, that's actually only 1 port. This is the 2nd port. So where's the 3rd port? Well, the answer is it's hiding underneath here. Now, under normal circumstances, you wouldn't want to take that off, because this is a venting port. It's not designed, this particular valve is not designed as a direction valve, which is how I'm using it. But having said that, there is an M5 thread in there, and I could, by putting a washer underneath there, turn that into a 3-port valve, so that I've got an in, and an out. So it is possible to do it, but I need a special fitting, like this special fitting here, which are difficult to get hold of because it requires an M5 thread on it. Now that doesn't matter, because the M5 thread is probably going to go through to a restrictor, so we don't need a huge amount of flow through there, so it's not a big issue. If you really want to go out and pay a small amount of money, then you go and buy this. You're going to have the same fitting there, and then you need a plug on there. So, you know, by the time you've paid out for extra fittings and this special fitting on the top here, you could well find that this is actually not such a cheap option. This works very well for certain applications, and it is specifically for charging and discharging cylinders, air cylinders. So in addition to this valve, you'll also have to buy some fittings, some push-in fittings. And those are the 3 fittings that you can see here at ports 1, 2 and 3. Now when the solenoid is not powered, what will happen is the air will pass in port 3 and out at port 2, and it will pass through a restricted flow valve, a restriction. And then it will reconnect back into the main line here at F with a T-junction. And it will pass out through the nozzle. So that means we shall get a very small controlled amount of flow to make sure that the nozzle is never ever without air. When we switch the power on to the solenoid, then this envelope here is the operative envelope, and if we shift these 3 lines across to here, we shall see that the flow is passing straight through, and it's blocked off there now, so it's no longer passing through the restrictor. And so consequently it will pass straight down this line and straight out. Unrestricted flow. So basically what we're trying to achieve here is unrestricted flow for cutting and restricted flow at all other times, including engraving. Connection CN1. Okay, so how does this circuit work? Well, as an engineer, this seems to work the wrong way round. I would expect signals to appear on these terminals 4 and 5. Now let me just explain. We've got 24 volt DC here, which is being supplied to this solenoid. We've got 24 volts, which is being supplied to this solenoid. And nothing's happening. So when you start your program off, pin 4 will actually, inside pin 4, there'll be a switch which switches that down to ground. And so consequently what will happen is your voltage, which is sitting here, will now be able to pass through the solenoid and down to ground. And so you'll have a circuit running through and you will energize this solenoid. If you're doing engraving, nothing else will happen. Because this has been energized, the pump will switch on, but of course the pump will switch on, but this one is not energized. So consequently, if you're engraving, it will be passing through the restriction and you will have virtually no flow, just enough protection flow at your nozzle. Now, if you move on to a cutting layer and you say, yes, you do want your air assist, then what will happen is this wind connection at number 5 will again switch down to ground. And consequently, what will happen is this line here will now be connected to ground and we shall have a circuit through here and we shall switch this solenoid on. And switching this solenoid on means that the air will now pass through this side straight through, and so we should get lots of air for our air assist. And what that means is that the pump will only ever switch on when we're running a program. But that could be very, very annoying when you want to do something manually or you want to test something. So as a consequence, what I've done, I've added a manual override. If the status switch is not connecting to ground, it means I'm not running a program. And if I'm not running a program, then the wind signal will also be dead. That will not be connecting to ground either. So if I want these two things to work, I have to force them manually. And so what I've done, I've provided an alternative route. Bear in mind, I've always got 24 volts sitting here, and I've always got 24 volts sitting here. But what I haven't got is a route to ground. And so what I'm doing, I'm providing an alternative route to ground for the status line, which basically switches the pump on. And I'm providing an alternative route to ground for the solenoid valve, the air solenoid valve. So that means the air assist will switch on. And if I want to do something manually and I don't need full air, I've still got my manual control valve on here, which allows me to control the flow manually. I've got complete manual control and I've also got automatic control. Now, I hope all that makes sense. I'm not going to drag you all the way through the process of wiring this and connecting it up, although I will show you one or two pieces that might be of interest to you. But the essence of it is this diagram with its parts list will be uploaded to the RDWorks Lab website, or you can write to me directly as you usually do, and I will post you a copy if you send me your email address by personal message on YouTube. Well, now that I know that I can mark stainless steel with this machine, I'm going to make myself a little label out of some very thin 0.5 thick stainless steel. Let's see how it goes. And what I'm going to do is to, with a piece of abrasive pad, I'll map the surface like that. There we go, that's quite a presentable label. Well, it's time to brutalise the machine again. Well, we've just put a piece of industrial strength double-sided tape on the back there. Well, I'm going to push that through there now. I'm not going to pop it in there, only just to rest it in there until I bring the cables through, because I don't want to fight with putting these fasteners on behind here when I can do it out the front here. Right, one small issue that I've encountered is that the controller does not come with a full set of connectors, and I had to buy this as a separate issue to connect the cables into CN1. So what I'll do, I'll put the description of this on the parts list, and then you can go to your own electronics component distributor and see if you can source something if you need to. Well, we've installed our switch and we've brought the cables in down the trunking and they're at the bottom here ready to connect into the controller. Now we've got to find a home for the solenoid valve somewhere around here. Now I'd like it to sit in the bottom. You can see where the input is. The air comes in here, and at the moment the air has been, this is a very thin soft pipe and it's been made to fit on there. Well, I've got to now replace that with a piece of 6mm polyurethane pipe, but the problem with this polyurethane pipe is it's got to stretch over something like a 7 or 8mm diameter there, which it's not going to like. So to try and help me, yeah, today I've not got coffee in here, I've just got hot water for about 15 or 20 seconds, and then hopefully there'll be enough stretch and flex in that pipe. I want to mount this valve here, so I've turned it that way round so I've got flex on this cable when I close the door. Yes, maybe it'll be safer to have it mounted up there. We'll just cut that short and put that pipe into port 1, and that will control all the pipe work. And there we go, that keeps all the pipe work out of the way. Okay, so now we've got to get our electrical connection to that. And for those of you that have not used these type of plugs and sockets before, there is a trick to getting into them. You have to remove the screw that holds it together, and inside the top fitting there's a little push thing which will enable you to break it apart. So until you take the screw out, you can't take the core out. Now I've only got some light 10 amp 3-core cable, so we don't need the third core because this is a low voltage and it's DC, so we don't need it earthed. Okay, now it doesn't matter which wire goes in where. Put the screw through, just give myself plenty of cable to get through the trunking. So this is all connected up, so all we've got to do now eventually is to just adjust this restrictor to limit the flow through the nozzle. I think we're all wired up now. The job took a bit longer than I anticipated because I finished up changing all the plugs and sockets on that service panel. Well, I've just turned the machine on and nothing has blown up. When I looked at the status output relay, it isn't working in the way that it should be. And I'm not even sure that the blower is working either. Now I seem to remember that you have to configure those within RDWorks using the vendor settings. So we're going to turn the machine on and we're going to have a look to see what's in the machine at the moment. Okay, so we go up here to vendor settings and it's RD1234 and that gets me to this page here. I really ought to read what's in the machine, don't I? Now let's go and have a look, see what's on. Other. You see I haven't got enable protect parameter and enable blower. They're not switched on. That's why it's not working. We better write that back to the machine and then we'll see what happens. So we've now gone too far. We've protected something that shouldn't be protected. Can't even use the machine now. Read. Take the enable protect off and write. Exit. Everything is working perfectly except the ports on the solenoid valve are not quite as I expected. So I've had to replumb the solenoid valve and it now works perfectly. I've stopped halfway through a cycle and therefore the pump is on and it's in quiet mode. And by quiet mode I mean it's producing some bubbles. And then I should be able to regulate the bubbles to nothing. And we need just a few bubbles like that. So I'll lock this restrictor up in that position. Okay, now this is paused halfway through a cycle. So that's why you can hear the pump running, and you can hear the pump running in a laboured form. So let's first of all complete the cycle by doing an escape. And once the cycle is completed, the pump switches off. So here we are at rest, and what I want to do now is to use the machine for some manual cutting. I want to use the arrow keys and the pulse key and hold them together. Now to do that I shall need some air assist, and so what I've got to do is to switch on to manual. So I've now got my full air assist on, and if I want to regulate the flow in manual mode I can do it with my control valve here. But normally I'd leave that valve fully open all the time because the machine is now going to deal with things automatically for me. All I've got to do is remember to write the programs with the appropriate if blowing yes or no on each layer, because I've been so used to just leaving it on that now I might possibly forget. Okay, let's just check the function of it back in auto mode. Well, there's auto mode. You heard the pump sits off now, so the pump will no longer thrash itself to death while I'm standing here talking to you. Now, I'm just checking my lens, and I don't know whether you can see that, but that's the bottom side of the lens. Now, I think that probably what I've done there, I've burnt the anti-reflective coating off of that lens when I did that stainless steel engraving. So I'll just give that as a word of warning to you because I've now buggered that lens. Now fortunately I have a spare lens that I can put in there. Even though I haven't got my cross flow on there at the moment, I've got enough air moving across to keep the debris away from the job. It's not being blown back down on the job. Now without changing any of the settings I can now see that it's cutting. Look at the smoke coming out from underneath. The all singing, all dancing air assist system now, and as you can hear the pump is off. The machine is on and the pump is off, and I didn't switch it off. Yes, I'm very pleased at all the little niceties that I've been able to include in this air assist upgrade on this machine. Now without the experience of the other machine and just putting the valve on it and allowing me to use the air assist on or off, the extra little bits and pieces that I've used on this machine really refine it to a nice degree, and I think I've now got what I call the super ultimate air assist on this machine. So thank you very much for your time, and I'll see you in the next session.